Welcome to Module 4, Lesson 10, Evaluating Statistical Claims, the last lesson in this module. So on the SAT, you might be asked to evaluate a statistical claim, and that involves determining whether a claim is valid or not based on the given data. So some key concepts for evaluating statistical claims. The representative sample. A sample must reflect the population that it represents. The sample size. Larger sample sizes generally lead to more reliable results, right? Like I said in the previous lesson, the larger the sample size, the closer it is to the population size. Bias in data collection. Data should be collected in a way that avoids bias, and we're going to look at some examples of that today. Correlation versus causation. The two of them are not the same. Two variables could be related, right? That's a correlation, but that doesn't necessarily mean that causation is happening, that one variable directly causes the other. The margin of error and the confidence interval, right? We looked at those in the previous lesson. And misleading statistics. Statistics can be presented in ways that exaggerate or distort reality. So some steps to evaluate a statistical claim. First, understand the claim. Examine the data, check the methodology, analyze supporting evidence, and consider alternative explanations, right? And I've included some questions here for you to keep in the back of your mind. And while you're working on these types of problems in this course and on the actual SAT, ask yourself these questions. So let's take a look at an example. A sample of students at Ruamrudi International School in Phuket, Thailand, are surveyed about if they prefer online classes. The results of the survey are most representative of what population? So A, teachers at Ruamrudi International School. Well, I don't think that's the answer because it's a sample of students at Ruamrudi International School. B, students at Ruamrudi International School. Yeah, that seems like it's the most appropriate answer here since the sample is of the students at the school. So I'm going to choose choice B. But let's just take a look at why choice C and D are incorrect. Students in Phuket, Thailand, well, then the survey should have surveyed students in all of Phuket. Or D, students who take online classes at Ruamrudi International School. Well, that just wouldn't make sense because the sample is of all students at Ruamrudi International School, not just the students who take online classes. So the next question says, which of the following sample methods is most likely to produce valid results? So how should the school conduct this survey to get the most accurate results? So A says, survey every fifth student to enter the school library. Well, that might not produce the most valid results because you're only surveying the students who enter the library, right? And we don't know how many students or who are going to enter the library that day. B says, survey every fifth grade 3 student to enter the school one morning. Well, I don't think that would provide the most accurate results because then we're only going to get an idea of what the grade 3 students prefer, not the students of the whole school. C says, survey every fifth student to enter the school one morning. Well, that seems like it would be the best option to get the most accurate results because you'll be surveying the entire school, right? Everybody has to enter the school that morning, no matter what grade that they're in. So taking every fifth student to enter the school one morning would provide you with the most accurate results. But let's just see why choice D wouldn't make sense. Survey every fifth student to enter the school talent show. Well, the entire school population might not be in attendance of the school talent show, so that wouldn't give us the most accurate results here. Please pause this video and work on the Lesson 10 Level 1 problems in the workbook. In level 2, we're going to understand bias in surveys. A bias in surveys occurs when the method of collecting data influences the results, leading to outcomes that do not accurately represent the population. So, sampling bias occurs when the sample is not representative of the population. An example would be surveying only students at a library to estimate how much all students study. Well, that wouldn't really be fair, right? Because students at a library are probably studying, right? So it's not an appropriate representation of the entire population. So let's take a look at an example. A poll of 100 people at a vegetarian festival shows that 80% prefer plant based diets. Can we predict the preferences of a city with 1 million residents? Well, the sample is biased as it focuses only on the festival attendees. And anyone who's attending a vegetarian festival is obviously already on a plant based diet. So the sample results cannot be reliably extended to the entire city. Please pause this video and work on the Lesson 10 Level 2 problems in the workbook. In Level 3, we'll draw conclusions from sample data. This will involve using information collected from a subset of a population to make inferences or predictions about an entire population. So, some steps for drawing conclusions: analyze the sample, calculate proportions, scale to the population, consider limitations, and evaluate the claim, right? And again, I've included some questions here that you should keep in the back of your mind. And as you're working on these problems in this course and on the SAT, ask yourself these questions. So let's take a look at an example. A study was conducted to determine if a new treatment is successful in treating sleep apnea. 500 participants were selected at random from a large population of people with sleep apnea. Half of the participants were randomly assigned to receive the treatment, and the other half did not receive the treatment. The resulting data showed that participants who received the treatment slept significantly better than those who did not. Based on the design and results of the study, which of the following is an appropriate conclusion? So A says, the new treatment is likely to improve the sleep of anyone who undergoes it. Well, that doesn't seem correct because where the study is only about people with sleep apnea, and the participants that were chosen are participants with sleep apnea, right? Not just anyone. B says the new treatment is better than all other available treatments in improving the sleep of people with sleep apnea. Well, we don't have any information about any other treatments. The survey is only being done with this particular treatment. So we can't say anything, and we cannot compare the result to the effectiveness of any other treatment. C says the treatment is likely to improve the sleep of people with sleep apnea. Well, that one seems the most accurate, right? Because the survey gave half of the participants the treatment, and the other half did not receive the treatment, right? And based on the results, the people who received the treatment did sleep better, right? So choice C has to be the answer. D says none of the conclusions are appropriate, but choice C is appropriate and very valid based on these survey results. Let's look at another question. A study shows that people who exercise daily eat healthier foods. Does this prove that exercising causes healthier eating habits? Why or why not? Well, no. Other factors such as your work schedule, daily routine, or income could influence your eating habits, right? Both exercising daily and eating healthy foods are a choice independent of each other. Right, so the data shows a positive correlation or a positive association between exercising daily and eating healthy foods, but not necessarily a causation. Please pause this video and work on the Lesson 10 Level 3 problems in the workbook. After you're finished with the problems in the workbook, you can move on to the next set of videos for Module 5.